Welcome back to my video. So for today, I'm going to talk about Chem 10 practice problem lecture 2. So for the first problem, it says unit of measurement. State the name of the unit, US or metric, and the type of measurement, length, time, mass, volume, etc. So the way you can determine whether it's US or metric is you can refer back to the book on page 39, table 2.7, some common equalities, and you could use metric or US. These are the only two you're going to be needing. So if you go back to letter A on number 1, it says 0.8 liters. I'm going to go back to my table, and under metric and US, I'm going to see which one has liters. So we see here that it falls under the metric category, and I see that it's considered volume. That's the type of measurement it is, and the unit is metric. So for one, I'd put for unit, I'd put metric since it was found under the metric system, and for measurement, type of measurement, it would be volume. So if I go to B, it says 3.6 millimeters. If I go ahead and move to table 2.7, I see that it falls under the metric system category. And for the type of measurement it falls under length. So I go on to letter C. It says 1.5 gallons. I'm going to take gallons and I'm going to look at the table 2.7. And I see that gallon isn't found in metric. So I move over to US and I find it right here in the volume. Type of measurement, it's volume. So I'm going to put volume, and it's found in the US system. For letter D, it says 5.0 seconds. So if I go and move over here, I'm going to look, and yes, I found it in seconds under metric system, under time. And if I go here too, I find it as well. So for this one, I'm going to put it's found in both US and the metric system, and it was found in the category time. So for letter E, it says 100 kilograms. And what I'm going to do is I'm going to look back at the table, and I do see that it's right here under metric system in the type of measurement mass, but I don't see it on the other side. So for this one, I'm going to put metric. It's measuring its weight, and it's found under the category mass. So for letter F, it says 98 degrees Celsius. I move over here, since I know it's degrees Celsius. I went back to my notes. If you need more understanding about this for metric, you can go ahead and go back to the notes, or you could read a little bit more on it. Okay, so for number 2, it says measured and exact numbers. Circle the exact number, if any, in each of the following pairs of numbers. So basically here you're just looking for an exact measurement. So what that basically means is you want a whole of something. You don't want partial. So when something comes to mind, exact. Like I ordered 1 box of pizza. You didn't order a 1/4 of a pizza. So you're going to go ahead and see. So for letter A, can you imagine it? So can you imagine 5 pizzas? Yes, you can. So that's an exact number. So then I move on here, and it says 5 blocks of cheese. Can I imagine 5 blocks of cheese? Yes. So I'd go ahead and underline it. I move on to letter B, 6 stacks of pennies. Can I imagine 6 stacks of pennies? Well, yes, I can. So that's an exact number. So now I move on to 6 grams of nickel. Can I picture, and do I understand what 6 grams of nickel is? No, so that's not an exact number. 3 pounds of onion. Can I picture 3 pounds of onion in my head? No. 3 kilograms of carrots. Now, can I imagine 3 kilograms of carrots? No. I move on to letter D, 5 miles. do I know what 5 miles is in my head? No. 5 cars. Automatically, when I think of cars, I know, okay, I know what 5 cars are. So that's an exact number. So the ones that were exact, I underlined them. And the ones that weren't exact, I circled them. Moving on to number 3, significant figures. How many significant figures are in each of the following? Underline them. So you can go ahead and refer back to the book for this, because there is a page where it talks about significant figures and rules. So for letter A, it does say 11.0 meters. So when I did this, I referred back to the significant figures, what was significant and what wasn't. And so when I did this, I counted 1, 2, 3. So basically anything that comes after the whole number, you can count it off. So 1, so anything that starts off, you can count it. So it'd be 1, 2, 3. I move on to letter B. I put 4 significant figures. Once again, I refer back to the book. And I got 4, so same thing. I have a whole number in the front, so I got 1. Well, actually 11. And then you count after that with the decimals. And I referred back to the rules. So I'd count 1, 2, 3, 4. So for letter C, it says 0.0250 grams. So the way I got 3 significant figures here is I remembered in the rules of significant figures that if there were zeros before any of the real numbers or whole numbers, and if they were before decimals, you don't count them. They're like imaginary zeros. Anything that comes after the real numbers or whole numbers, you can count it. But anything before starts with 0 or decimals, you don't count. So right here, if I have 0.205, I know that I can't count the imaginary 0. So I'd go after that, and I'd count 1, 2, 3. Now here too, I'm going to go to letter E. It says 0.0012 seconds, or 0.00012 seconds. So for this one, same thing. Anything that's imaginary zeros in front of the real number or whole number, you don't count. So I just count 1, 2. I have 2 significant figures there. Next one, okay, so these ones are tricky, but you just go ahead and refer back to the book. But for letter F, I would only end up with 2 significant figures because there's a comma, not a decimal. So yes. For letter G, it says 250.0 liters. So same thing again, I referred back to the book and ruled out my rules, and I counted 1, 2, 3, 4 significant figures. Anything that comes after a real number or whole number. H, I have 2.5 times 10 to the negative 2. So what I did was I know that my exponent is negative, and I have my number here. So since I have my number is times by a negative exponent, I move it to the left. If you had a positive exponent, you'd move it to the right. So since I have a negative exponent, I start from where it was, the decimal place, and I move it over to the left 2 times. So I go 1, 2, and I see there's 2 imaginary zeros, so I just count 1, 2 significant figures. At any time, you could stop this video and refer back to the book. It does help if you read it over and over. Okay, so number 4, significant figures in multiplication and division. So for these ones, how I did the significant figures. So for letter A, all I did was I also referred back to the rules of sig figs, but for multiplication and division. So when you multiply, you take the smallest significant figure and that's what's going to end up as your answer. So remember to count the sig figs before you do the problem. So once you have your problem, you know how many sig figs you need to have. So here I have one significant figure. There's no decimal after the real number, whole number. And I have 3. So which one is smaller, 1 or 3? 1. So I'd go with one significant figure. So once I did all my work, I got 74,000. But I remembered, oh shoot, I need one significant figure. So I'd round it, since 4 is less than 5. I'd round it down, so it'd stay at 70, since I know I needed just one. So for letter B, same thing. I look at my sig figs, and I see that I only have 1 because of the 4. And this one's 3 and 3, but my smallest one is 1. And when I got it in total, I had 0.0045, and I saw that after I needed one significant figure, which was a 4, and I see that I had 4 5, so obviously 5 is greater. So I'd round my 4 to a 5, and I'd have 1. So I'd end up with 0.005. Next one is letter C. So same thing, my smallest sig fig was 2. Out of my whole problem, I did all my work. This is what came out on the calculator, 15.147. And I remember I need 2 sig figs, but the 1 is smaller than the 5. So, So I wouldn't round it up. I'd leave it just as is. And last but not least, I did all of this. And my smallest sig fig was 2. And I did all my work. I got this answer, 0.00554308. I know I need a 1, 2 sig figs, and the 4 was smaller. I don't round it up, so I leave it at 0.0055. Okay, order of operations and sig figs rules. So right here, same thing. You do your significant figures. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. And since they do have this one's only to the 10th place, and these ones have more, I know that I only have 2 sig figs here. You don't count these. You also refer back to the book if you don't understand this, and you do your rows of sig figs with your order of operations. And I got 50, because when I put it into my calculator with all my work, I got 49.50344. Okay, so fill in the definition of the following prefixes and answer the question. So you can go ahead and refer back to the book, but if you don't know this by the top of your head, letter A says centi. When you think of a centimeter, what first comes to mind? Cent. So centimeter. Cent, 100. How many cents are in a dollar? Stuff like that. So centi equals 100. How many meter is in 1 centimeter? So I referred back to the book, and I found out that 0.01 meters equals 1 centimeter. Or you can do, I believe, 1 divided by 100, and you'd get it. How many centimeters is in 1 meter? So right here, you know centimeter is 100. So you would just do 1 meter equals 100 centimeters. So milli equals what? 1,000. How many grams is in 1 milligram? So you would divide 1 divided by 1,000, and you'd get 0.001 grams equals 1 milligram. How many milligrams is in 1 gram? Then you just reverse it, and you'd get 1,000 milligrams is in 1 gram. And that's it for Lecture 2, Practice Problem for Chem 10. If you do have any questions, you can go ahead and reread the book in this section, or you can go ahead and watch this video as many times as you want. Thank you for viewing, and I hope to see you soon.